Hello everyone, today we are going to start lecture 04 of class 8 mathematics chapter number 6, which is squares and square roots. Now in this lecture we are going to talk about the methods which are available to find the squares of numbers. Now you must say that we find the square by multiplying the number by itself, right? So if you have to calculate square of 11, you will do 11 into 11. But no, we do have some other specific methods which kind of make it easier to calculate the square of a number, right? So what we are going to study is that in order to find out the square, in order to find the square of a number, comma, we multiply the given number by itself. Okay, so basically what we do is we multiply itself, but this method is kind of you can say convenient only for the small numbers. We can say that the multiplication method, which is actually the basic method, this multiplication is convenient for small numbers, only, right? But when the numbers become large, then this method becomes tedious and time consuming. So we should develop some other methods. Okay, so the shortcoming of this method is that for large numbers, multiplication may be time consuming. Okay, there is another word for it, you can call it tedious. Okay, so it may be time consuming, tedious, or you can also call it laborious. That is, it is kind of doing a labor work. So this method is not very convenient for all the numbers, and that is why we shall discuss some other methods to calculate the square. There are some other methods. Which takes less time. Right? So let us talk about the methods. But again, before starting the methods, let me remind you again that you have to learn the square of natural numbers till 1 to 30. If you do it till 50, it will be very well enough. But if you do it 1 to 30, it is kind of it will become easy to actually solve the questions and to actually find out the squares, because most of the questions based on finding the square actually employ the squares of natural numbers from 1 to 30, right? So this is a healthy reminder and you should always learn them. Now let us start with the first method. This method is called column method. This is very easy and it is just a 4-step method which actually helps you calculate the square of 2-digit numbers. Okay, so let me introduce the method. Let us talk about the working principle. So this method uses the identity. Which is very well known, which is a square plus 2ab plus b square for finding the square of a 2-digit number. Now you can very well see that this method has a limitation, and the only limitation is it can be used only for 2-digit number, but for them also it is highly effective. Okay, but in this 2-digit number, what is the unit digit and what is the 10 digit? Okay, so Here it is very well specified, where A is the tens digit and B is the unit digit. Right. So if you have A at the tens digit and B at the unit digit, then the square is A square plus 2AB plus B square. Okay. And these columns actually help you to calculate them. Okay. So there are following steps. Let me talk about the step number 1. Now this step says make three columns and write the values of A square, 2 into A into B, B square respectively in these columns. Right. Now to understand this method further and to actually follow the steps while calculating a square, let us take an example for this question. Let us take example. Let the sake of learning this question, let us take AB is equals to 57. Now let me remind you, AB is not A into B. Okay, here B represents unit digit and A represents tens digit, so it is a 2-digit number where A is equals to 5, and remember A is a tens digit and B is equals to 7. So basically you are going to calculate the square of 57. Okay, so let me fill up the entries in the columns as per the step number 1. So this is column 1, this is column 2, and this is column number 3. According to the question, or you can say according to the steps, we have to fill A square here, 2 into A into B here, and B square over here. So A square, which is 5 square comes out to be 25. 2AB, that is 2 into 5 into 7, comes out to be 70, and B square comes out to be 49. So this was the step number 1, in which we have to actually make 3 columns, and to take an example, we have to fill A square, 2AB and B square in these 3 columns. Right. Now let us talk about the step number 2. Okay, let us see what step number 2 says. Step says underline the unit digit, of B square and add its tens digit. Then add its 10 digit if any, 2 into A into B in column 2. Obviously 2AB is the column second. So to understand this, let us first bring the question to the current scenario. So this was column 1, this was column 2, and this was column 3. This was made for A square, this was made for 2AB, and this was made for B square. We have already calculated A square to be 25, it to be 70, and this to be 49. Now this method starts, and this method says that underline the unit digit of B square. So unit digit is 9, so let us underline it. Now add its 10 digit. Yes, there is a tens digit 4 because it says if any. So yes, there is a tens digit present. Add it to column 2. So we have to add this tens digit to column 2, and when we will calculate, we will get 74. Okay, So that is what this method actually says. So that is the step number 2, right? Okay, let us talk about the step number 3. Now before coming to step 3, let us bring the question to the present sense. So it is column 1, column 2, column 3. I am doing this again and again so that you just learn the method while I am explaining it to you. So that is a square. Then this column is for 2ab and that is for b square. Then what we did was we calculate 25. Now in this way you will repeat this method 2 to 3 times till we reach to the final step. So it would be 70, it would be 49. Underline the unit digit, add it here, add the tens digit here, and you will get 74. Right. So this was the stage where we have left the question in step number 2. Now let us see that what step 3 has to offer. Okay. So this step says underline the unit digit, underline the unit digit in column 2, so you have to underline this unit digit. Okay, we'll do it once we finish writing. So underline the unit digit in column 2 and add the number formed by tens and other digit, formed by tens and other digit, comma, if any digit is left, if any, to a square, obviously in column number 1. So let me first rephrase. Underline the unit digit, or we just read the step number 3 that says underline the unit digit. So unit digit in column 2 comes out to be 4. And add the number formed by tens and any other digits. So is there any other digit than tens? No. So add this number. So we have only tens digit to the a square, right? So what we did was, first of all we underlined the unit digit here, then added the remaining digits to column 2, then we underlined unit digit here, then added the remaining digits to column number 1, and finally we will get here 32, right? So now the final step is very easy, and it just says that what does the final step says. But just before the final step, let us again bring the question to its present sense. So column 1, column 2 and column 3, a square, so 2ab and b square. Now you will just memorize the method. So it will be just 25, then 2ab was 70, then b square was 49. We underline 49, we added 4, we got 74. We underline 4, we added 7, we got 32, right? Now the final step says, that is the step number 4. Now what this step says, underline the number in column 1. Okay, so this step just says that you have to underline this. Okay, these both are already underlined, 4 and 9. Now the final step says write the underlined digit at the bottom of each column to obtain the square of the given number. Full stop. Okay, so let us write them. So the underlined digit here was 32, here it was 4, here it was 9. Okay, So this basically implies that 57 square comes out to be 3249. Okay, so this was the complete method. So let me recall the method. Let me take you through the method. The first step says that make 3 columns. Right? Calculate a square, 2ab and b square. First of all, you have to find out what is a and b. A is the tens digit, b is the unit digit in your 2-digit number. Underline the unit digit in column 3, add the tens digit to column 2. Underline the unit digit in column 2, add the tens digit to column 1. Write down all the underlined digits and you will get the square. So let us see with the help of a question how this method actually works and how this method is actually helpful. Okay, so we have to find the square of 47 using column method. So first of all, let us see here. AB equals to 47, which implies that A equals to 4 and B is equals to 7. Right, now this is column 1, this is column 2 and this is column 3. Okay, this is A square, this is 2AB, B square. So here we have A square, that is 16, 2AB, that is 2 into 4, 8 into 7, that is 56, and finally we have 49. Underline 9, add 4 here, so you will get 60. Underline 0, you will add 6 here, so you will get 22. Underline 22, so 47 square would be 2209. I think you all get it. Okay, so it was that easy. Let us take another question so that we can again apply this method. Okay, now in this question we have to find the square of 86 using the column method. Okay, so AB here it is 86, which implies that A is equals to 8 and B is equals to 6. So here it is, you can directly write A square here. Okay, and you can write B square over here, 2AB over here, and then B square over here. Right, so A square is what? 8 square, that is 64. Then you can set 2AB, that is 2 into 8 into 6, and into, so it would be 96. B square would be 6 into 6, 36. Right, okay, so let us underline the unit digit here, add the tens digit here, so we will get 99. Then we underline the tens digit here, then we'll add 9 here, so we will get actually 73. Underline them, then write all the underlined numbers below in the last column. So it will be 7, 3, here it will be 9, here it will be 6. Okay, so you can very well see that 86 square is nothing but 7396. Okay, so it was that easy to apply column method. So this was all about column method. Now let us talk about another method, which is diagonal method. Now this method is also very easy, but also it has various steps which we have to study, right? So the first thing which differentiates it from the column method is that this method is applicable to find the square of any number. This method is applicable to find the square of any number irrespective of the number of digits in the number. So that is the biggest advantage we have with the diagonal method. Okay, so since the column method was only restricted to the 2-digit numbers, this diagonal method can be expanded to any number of digits, right? So let us talk about this number and let us talk about the steps, that how do we use the steps to find the square with the diagonal method. So let us talk about the step number 1, which we have to apply in order to use this method. So this step says that first of all obtain the number and count the number of digits in it. Okay, so let there be n digits. Let there be n digits. Okay, in the number to be squared. So the number you have to find the square of which let us the number have n digits. Okay, so now this method says that we have to make n square subsquares. What? N square subsquares. That is, we have to make a particular square array of n by n. Okay, so this says, step 2 says that draw a square and divide it into n square subsquares. That is small squares which are n square in number. So there are n by n squares. Okay, n squares of the same size. How? Of the same size by drawing. That is how we will make it, by drawing n minus 1 horizontal and n minus 1 vertical lines. Right, so we will make a square. Suppose you have a 3-digit number, so this basically says that you have to make 9 squares. Okay, 3 square is 9. If you have taken a 4-digit number, you have to make 16 squares or 16 subsquares. Okay, so that is basically the number says, or the method says. So let us talk about the step number 3, which actually says that draw the diagonal of each subsquare. Draw the diagonal of each subsquare, full stop. Okay, let us take for example, let the number 2 be squared. Let us take 479. Okay, for the sake of explaining this method, let us take a 3-digit number. So we have to make 9 square. Okay, so let us take 479, and in the course of understanding this particular method, let us square the number 479. Okay, so according to the step number 1, we have made 9 squares. We have made one big square and we have divided into 9 small squares. Okay, so that was step number 1, that obtain the number, count the number of digits, let there be n digits. What step number 2 has said? Draw a square and divide it into n square subsquares. So n equals to 3, so we have made 9 subsquares. Right, now step number 3 says that draw the diagonal of each subsquare. So let us do that. Let us draw the diagonal of each subsquare. So in this way we can draw the diagonals of each subsquare. So finally we will reach here. Okay, now step number 4 says, write the digits of the number to be squared. Write the digits of the number to be squared along the left vertical side along the left vertical side and top horizontal side of the square, as now since your number is what, 479, so it says write the digits of the number to be squared along the left vertical, that is this particular side, left side, and the top side. So our number is 479. So we have to write it like this, 479. Okay, so this was the step number 4. It was actually very easy, right? Now let us come to the step number 5, which is the most important step because it shows how to multiply these particular digits. Okay, so step number 5. Now again, to make step number 5, let us first of all bring our, or we just make the diagonals as in the previous step, so that we can follow the next set of steps. Okay, then we have written 479. We had written 479. Okay, so let us see what this step has to say. So according to this step, multiply each digit on the left of the square, with each digit of the square on the top of the column, right? So multiply each digit on the left of the square with each digit on the top of the column one by one. So we'll do it one by one. Okay, then after multiplying the digits, so let us first multiply and then we can write the next of the step. Okay, so let us just multiply. Now it says multiply each digit on the left of the square with each digit on the top of the column one by one, and then we have to write the unit digit of the product below the diagonal and tens digit above the diagonal. So okay, let us first complete this one by one. So we'll have write. So the instruction says that write the units digit of the product below the diagonal of the product, and tens digit above the diagonal of the corresponding subsquare. What are subsquares? This by this square, this small, there are 9 subsquares actually. So now they say multiply each digit one by one. So we have to multiply 4 by 4, 4 by 7, 4 by 9. Okay, similarly 7 by 4, 7 by 7, 7 by 9. So this we have to multiply. And how do we have to multiply? Obviously there will be 2 digits number. So it says the unit digit should be written below the diagonal and 10 digit above the diagonal. So 4 into 4 is what? 16. So it says that write 6 here and 1 here. Right. 4 into 7 is 28. So it says that write 8 here, 2 here. Okay, so you can see unit digit of the product below the diagonal and tens digit above the diagonal. Okay, so now you must have got the pattern. 4 into 9 is 36. So write 6 below the diagonal, 3 above the diagonal. And it cannot be, since this method has been made so brilliantly that any single digit number with a single digit number cannot exceed 2 digits. Okay, so maximum number can be 9 into 9, so it is 81. It is also a 2 digit number. So you will never have to face a condition where you will get a 3 digit number. Okay, so this method has been designed so brilliantly. Now 7 into 4 is 28, so write 8 here, 2 here. 7 into 7 is 49, so write 9 here, 4 here. 7 into 9 is what? 63, write 3 here, 6 here. 9 into 4 is what? 36, write 6 here, 3 here. 9 into 7 is what? 3 here, 6 here, 63. 9 into 9 is 81, so 1 here, 8 here. So this was till step number 5. Now the final step will actually help us to calculate the square, and it is the most important after this step. This step still holds the most value, okay, because if you do not do the multiplication correctly here, or you skip some numbers, then it will cost you in the step number 6. So let us first talk about the step number 6. It says starting below the lowest diagonal, sum the digits. Starting below the lowest diagonal, sum the digits along the diagonals so obtained. Right, so it says that starting below the lowest diagonal, sum the digits along the diagonals so obtained. So first of all, let us bring the question to the current form in which we can apply this particular step. So we have to make the diagonals of the square. The number was again I am doing this just to remind you that how to apply this method. Okay, it is very easy to do so. 4, 7, then we had 9. Okay, we had 16 here, and 7 into 4 28, so 28 here. 36, so 36 here. 4 into 7 28 here. 7 into 7 49 here. 9 into 7 63 over here, right? Then we have 36, then we have 63, then we have 81. Okay, so this is the step. Now this says that starting below the lowest diagonal. So this is the lowest diagonal. Okay, it says starting below the lowest diagonal, sum the digits along the diagonals so obtain. So let us first complete the step, then I will show you what it actually says. Sum the diagonals, sum the digits along the diagonals so obtain. Then it says that write the units digit of the sum and write the units digit of the sum and carry the tens digit and carry the tens digit if any to the diagonal above as shown below, right? This you have to follow shown below as I am showing you, right? So carry the tens digit if any to the diagonal above as shown below. So where are the diagonals? So let us first draw them. Okay, and you should be very careful while drawing them. This method has to be taken care with like this. So this is the first diagonal. Okay, now this is the second. Actually we are taking the digits, like this is the lowest diagonal. Now in this diagonal and below this diagonal, so there is 3 8 3, so that follows another diagonal. So that is what we are talking, right? Similarly between 6 6 9 6 6, so that is another diagonal. Okay, so we are this is along the diagonals. Okay, so we are moving between these two diagonals. So one was actually along this diagonal, then 3 8 3 along this diagonal, then 6 6 9 6 along this diagonal. Similarly we have 3 8 4 8 3, so that are also diagonal numbers. Similarly we have 2 6 2, that is again a diagonal number. Okay, and then finally 1. Okay, so we have drawn them. Now it says that sum them. Okay, so now 1 has nothing to do with it, so 1 is actually like this only. Now what we have to do is we have to sum them. Okay, so 3 plus 8 plus 3. So first of all we have to make their sum. So it would be like this: 3 plus 8 plus 3. Right, now it comes out to be 14. So it says that, now this says that write the unit digit. We have summed the digits along the diagonal so obtained. So we have summing the digits. Okay, now this the next part says write the unit digit of the sum and carry the tens digit, if any, to the diagonal above. Since there was no tens digit, we have written 1 here. Now the unit digit is 4, so write 4 and carry 1 here, and carry 1 to the upper stage. Now what upper stage is? Upper stage actually does 6 plus 6 plus 9 plus 6 plus 6, and this 1 which you have carried, so I am underlining 1 this, so this is the carry, so it will come out to be 4, it would be 34. So it will be 34. Now again the unit digit here is 4, so you would write 4 over here. You would write 4 over here. Okay, and since 3 is the tens digit, so it is taken as carry above. Now again we have to sum these numbers along the diagonals. So these numbers come out to be 3 plus 8 plus 4 plus 8 plus 3. Okay, these are, and this 3, this carry 3. So it would turn out to be 11 and 4, 15 and 8, 23 and 26. It would be 29. Right. So again the unit digit is 9. So we'll write 9 here and we'll carry 2 over here. So let me underline 2 because we are taking it carry. Right. Now again under this diagonal there is 2, 6, 2. So let us sum them. So it would be 2 plus 6 plus 2. And this carry 2 also would be there. Okay, so it would be 8 and 2, and this would be 12. So again 12 has unit digit 2, so it will be written like this, or you can make them to the same level. Okay, you can actually draw this here and then you can write 2 over here, and this one again is to be taken as carry. So in this diagonal it would be 1 plus 1, this 1 and this carry 1, it would be 2 only, so we'll write 2 over here. Okay, so let me actually change the colors over here so it would differentiate with the rest of the numbers. So here it was, I think here it was 2, here it was again 2, it was 9 over here, it was 4, it was 4 and 1. So let me again walk you through the steps. It says that write the numbers 479, 479 and with the subsquares. Then multiply the digits and write the unit digit below the diagonal, tens digit above the diagonal. So you have maintained the question. Then start adding the numbers along the diagonal. You have added 1, so write 1. Then you will add 3 plus 8 plus 3. It would turn out to be 14. So write only the unit digit. Carry the ones digit to this addition. Okay, tens digit to this addition. So 6 plus 9 plus 6 plus 6 would be there, and 1 would be carry from here. So it would come out to be 34. Then again write 4 over here and carry 3 to this particular summation. Then 3 plus 8 plus 4 plus 8 plus 3, and then one more 3 of carry. You will get 29. Write 9 over here and carry 2 to this summation. So 2 plus 6 plus 2 and then one more 2. It would be 12. Write 2 over here. Then again carry 1 over this summation and it would be like this. Now you can very well guess what is the square. Okay, so it is very easy. So the final step number 7 says obtain the required square by writing the digits from the leftmost side. Right. Therefore, if you can see leftmost side, the square is 229441. Right. So you can very well say, therefore 479 whole square comes out to be 229441, right? So now you can practice more questions on this particular method and then you will find it very helpful. Okay, now let us come towards some particular methods which are actually very short and they will help you to calculate the square of some specific numbers, and they are very easy. So the first number one will be is the square of a number of the form A5. The square of the number A5, that is a two-digit number ending at 5, where A is the tens digit, 5 is the units digit. Okay, is the number which ends in 25 and the number A into A plus 1 before 25 is the number ends in 25 and has the number this before 25. So let us take an example and understand what this method is. For example, this works for two-digit number only. Okay, so let us take a two-digit number. Let it be 65 because it has to end at 5. That is why I call them particular methods, because they are not general. They will only serve for the number 15, 25, 35 till 95. This particular method. Okay, so here if you take 65, here A is equals to 6 and 5 is equals to 5, right? So this method says that 65 square will end at 25, but the number here would be A into A plus 1. So let us calculate A into A plus 1. So A into A plus 1 will be 6 into 6 plus 1, that is 6 into 7, which will be 42. So A into A plus 1 is 42. So this will be 4225. So here we will have 25, right? So that easy is this square. Okay, let us take another example so that you can understand how easy it is. Okay, let us take 85. Now calculating it will be a bit time consuming. Here A is equals to 8. Okay, because we only have to see tens digits. So what will be A into A plus 1? It will be 8 into 8 plus 1, that is 8 into 9, which would be 72, and obviously it will end at 25. So 85 square would be nothing but 72 because of A to A plus 1 and 25 because it is already been fixed. So you can clearly see this method is very fast when it comes to calculating the square of two-digit number ending at 5. Okay, similarly we have another rule which says that the square of a number of the form 5a, now it is opposite, it is also a two-digit number but starts at 5. So this is for 50, 51, 52, 53 until 59. Okay, so you can use this is where A is a unit digit and 5 is a tens digit, equals to 25 plus A into 100 plus A square. That is 5A square equals to 25 plus A into 100 plus A square. So this square is like this. Let us take an example. Let us take, since it is applicable only for the numbers 50 to 59, let us take 56. Okay, example. Let us take 56. So this particular method says, first of all identify A over here. So here A is equals to 6. So according to this method, 56 square is equals to 25 plus A, which is equals to 6 into 100 plus A square, which is 6 square. So if you calculate it, it will turn out to be 31 into 100. So 3100, which is very easy to calculate, plus 36. So it will be 3136. So that is how fast you can calculate the square of 56. Let us take another example. Let us take 59 for instance. Okay, let us take 59. Here A would be 9. Okay, we just have to calculate A. So 59 square according to this method would be what it says, 25 plus A, that is 25 plus 9, but and then it would be multiplied by 100, and then we have to calculate A square, which is equals to 9 square. So 25 plus 9 would be 34, so it would be 3400 plus 81, so it will be 3481. So that is fast how you can calculate the squares. Okay, let us again talk about some another method. Okay, so these methods are generally based on 5, as you can see, right? Now this method says it can be used for 3-digit numbers, so it is a bit versatile, you can say. It is exactly actually the extension of rule number 2. Okay, this says the square of a 3-digit number 5AB, where A 5 obviously is the hundreds digit, A is the tens digit, and B is the units digit. Okay, is given by 5AB square. You can see there it was 25, here it is 250. There it was A, here it is AB. There it was 100, here it is 1000. and there were a square, so it is ab square. So a is replaced by ab over here, and 25 and 101, they got 10 extra. Okay, so that is how you will remember this method. So let us take an example and see the applicability of this method. So what it says is, it basically says that let us take 527 for instance, because the number has to start with 5. So a is equals to, I think, 2 and b is equals to 7. So according to this method, 527 square, according to this method, 527 square, it will turn out to be what? 250 plus AB, that is, it would be 14 into 1000, then AB, that is 14 square. Okay, so if you are thinking that it is A into B, then it is wrong. Okay, that is why I have written 14. You can clearly see that is the biggest mistake which you will commit while doing this method. Since it is 7, so its square would end with 9. Now you can see 14 square ends at 6, right? 14 square ends at 6. So it is not 14, it is not product of the numbers. Okay, so you must remember that actually it is a 2-digit number formed by them. Okay, so that is what it would be, 27. That is 2 and 7 is not 2 into 7. That is AB, that is 27, and here we also have 20. Now you can very well see, I am reminding you with all the lectures that you have to learn the squares from 1 to 30 and see 27 square is being used over here. Okay, so it would be what, 250 plus 27. So it will be 277. So it is very easy to calculate, 277. Yes, and if you know 27 square to be 729, it would be very easy to you, because of these 3 digits you just have to add this number replacing the zeros. Okay, and that is basically the reason which actually increases the productivity of this particular method. Okay, similarly, if you have 514, then here A is equals to 1 and B is equals to 4. So you can have A is equals to 1 and B is equals to 4. Then you will have 514 square. So it would be 250 plus, now 2-digit number is not 1 into 4, it would be 14. Okay, and it would be into 1000 plus now 14 square, right? So it will be 264. So it will be very easy, because 264 and you just have to add 3 zeros. And then what is 14 square? 14 square turns out to be 96, and it does not look like 4. Okay, so we should make it look like 4. Okay, 196. So you would get 264196. I hope you all are getting that how these methods are making the calculations so easy. Then we have at last the method rule number 4, which actually is kind of extension of all of these numbers, right? It says that your number should be starting with A, B, C, but it should be ending at 1. So we have studied rule number 1 where the number was ending at 5. Okay, so it is something like that only. So it is just an extension to n number of digits. So square of a number a, b, c dot till 5, that is a number having 5 at unit place, is obtained by affixing 25 to the right, as we have seen in the rule number 1, and the number should be a into a plus 1. Okay, or sorry, n into n plus 1, where n is the ABC. That is if you see the extension of rule number 1 only. So let me give you some examples. Let us take 125. Now we are taking only a 3-digit number. You can also take a 4-digit number. So if you are taking just 1 to 5, it is ending at 5. Now what you just have to identify what ABC. Here we have only AB, not C, right? So let us calculate. AB is equals to n over here. Here n equals to 12. Okay, this is the AB because it is at ending at 5. So it is n. So if n equals to 12, so n into n plus 1 you could calculate easily. So it would be 12 into 12 plus 1. So it is 12 into 13, which turns out to be 156. So if you calculate 125 square, it would turn out to be, it would end at 25, but it would be accompanied by 156. That is n into n plus 1. So it will be like this. Let me again show you. 125 in this, leaving 5, everything would be ABC. So here we have AB only, we have to assume it. And again, it is not 1 into 2, it is a 2-digit number formed by these digits. So AB is equals to N. So it will be 12. So it will be a 2-digit number. Then N into N plus 1 would be 156. Then N into N plus 1 would be the predecessor in 25. So 25 is fixed to the right, and then we have to fill this particular gap by N into N plus 1. Let me give you a 4-digit number and see that how fluently this method works with a 4-digit number too. Let us take 1, 2, 3, 5. So it is a 4-digit number. Leaving 5, this will be ABC over here because it is a 3-digit number. So here ABC equals to N, which implies that N equals to 1, 2, 2, 3. It is not again 1 into 2 into 3, it is a 3-digit number 123, which again gave us that N into N plus 1. So that is the only calculation which we have to do, that is 123 into 123 plus 1, which would come out to be 15252, right? So according to the method, 12352 square would turn out to be 15252, that is N into N plus 1 and 25 at last. Okay, so these were the methods which are available to calculate the square of a 2-digit number, 3-digit number, okay, without even multiplying the number. So I hope you all enjoyed the lecture and you all got some new information regarding calculation of squares, okay, with the help of these particular methods. So we'll meet in this lecture, we'll meet in the next lecture. Till then, goodbye.